done, besides making a ridiculously long short answer test, is try to merge 7 minutes of questions for those. Did you look at those?
Yeah.
If you teach AP, it's ridiculous. All right, so anyways, is they try to merge like 4 or 5 concepts within one question. And what I really like about this demo is this merges like 4 or 5 concepts within one demo. And so I'm going to kind of walk through it, and I haven't done this in a few weeks, so I don't remember it at all. But what you're basically doing here is you're taking some hexane or any other non-polar solvent and putting it into the test tube here. And what I like about it is it's a very complicated chemistry, but it's very forgiving. And one of the things I don't like about AP demos sometimes is that if you're 1 drop off, it's done. And I'll be like, and I'm always 1 drop off in more ways than one. And so this here now has some copper sulfate solution, and it says about 25 milliliters. What is that, like 23? All right, and so then you mix it together here. And so then you mix it together, and you'll notice here that after you do this, they will separate back out. So we're talking about the nonpolar interactions, ion-dipole interactions within the bottom layer, and the nonpolar interactions in the top layer. And that's why it is not reacting, or any sort of interactions. And so then what you add here is you add some potassium iodide here. And I'll come a little bit closer here. And so it's 1 to 2 milliliters here of potassium iodide. What we see is we see a precipitate forming in the bottom here. But then what's really cool here is maybe you see it at the top of this layer. You got to see maybe some red. And then what we're going to do is we are going to shake this again. And then we see a color change, which is always kind of cool. And then we let this settle out here. And all of a sudden we're noticing a new color here up top. All right, and the chemistry is kind of described there. I could walk through it a little bit more. But basically what we're doing here in this is that this is a redox reaction here. And what we're forming is that first reaction is that when we are adding the Ki, we're turning the copper 2 into a copper 1 ion. And we're making I2. And that I2 is now selectively soluble up in the nonpolar layer. Okay? And so that's a pretty cool demo. And then what's nice is that we mess with it. We mess with that equilibrium. So we're dealing with an IMF demo, but then we are going to put a equilibrium into play. And so then the next thing that we are going to do is we are going to add some concentrated ammonia here. And every time I add concentrated ammonia to something, it all drips out, which is a science demo in itself. And I'm always like, science. So unless I set off the smoke alarm with concentrated ammonia.
Well, we have heat detectors.
Yay! Awesome. So now what I'm going to do is to add some concentrated ammonia here, and you'll notice that when it hits the copper layer, we get this blue color. And then what I'm going to do is I'm going to shake it again. We'll see what happens then. Ooh. So now, so what we'll notice is by adding this, we are getting this nice deep blue color, but then what else are we noticing?
Most of the ID.
Most of the I2 is gone. Because what is happening here, and I can mess with how much I shake it, and I can also mess with how much ammonia I'm adding in. And now it's even clearer here, which is kind of cool. So what I'm making here is I'm making an ammonia complex with that copper ion, okay? And with that equilibrium, now I am removing copper 2 ions, okay? Ooh, I'm gonna cover up this ammonia, hold on. So I'm removing those copper 2 ions from that first equation. Now, I don't know how much shift you guys go into in your class, but we deal with a lot of shift, okay? I pile it on, you know, until they're sick of the shift. But what we have, shift happens in chemistry, it really does. Okay. I've never slipped on that. And you have, yeah.
I wrote it on the board without the F one.
Nice. So when you are, yeah. Well, you're more full of shift than I am. You've been teaching longer. So. So what you're doing is you're removing the copper-2 ion, which is going to shift the reaction more to the left to produce more copper-2. As it produces more copper-2, it's going to remove the violet from the top layer. Okay? And so then what we're going to do is, they kind of get the trick here from there. Now what we are going to do is we are going to add some 6 molar nitric acid to this. And we will see what happens here. Okay, now we're adding some 6 molar nitric. Let's see when it hits the interface, and you can see it that it goes down at the bottom there. We get a little bit of a reaction here. Now let us see what happens when we shake this again. So we see it reacting at the bottom, and then we're going to shake it again. And I didn't add enough. That's nice. All right. And so we're noticing here that this goes back up. The pink goes back up into that layer. Let me add just a little bit more. There we go. That's nice. All right. And so now that, yeah. So now we shake it even more, and we notice it gets hot. But we're seeing again this reaction occurring, and now we're getting this pink back up at the top. And so in that case, what we are doing is we're adding some nitric acid. As we're adding the nitric acid, it's going to react with that ammonia. And so then, this is where we get a whole bunch of shift. We remove, the nitric acid removes that ammonia, which shifts that complex ion to the copper-2 blue, which then goes back up here and reshifts the top reaction to the right, producing again the iodine and the copper-1. So there's a whole lot of chemistry going on there, and you can spend a whole lot of time talking about that. And it's really cool because it's a cool demo, but there's a lot of concepts that you could tie together at once with it. So thanks, Paul, for showing it. Wow.